today we are building yet another, don't fall, yet another electric dirt bike project. Now this is a Suzuki RM 125cc two-stroke dirt bike, and this is a QS 13890H electric motor. Now, I know I've built how many other electric dirt bikes, but this one's going to be different. We're not simply just going to be taking this two-stroke engine out of the frame and replacing it with the electric motor. We're not doing that, so it's too easy, it's too simple. We're going to be converting this two-stroke engine to adapt this electric motor into the engine, so therefore we still have gears and still have the clutch. Now, I know it's very similar to what I built with the electric pit bike project. It's basically the same thing of what we did with that project, but that one, it's a lot of fun, it works great. It's really underpowered. So I want to do it again, this time with a normal sized dirt bike and a much more powerful electric motor. So honestly, I'm not really sure exactly how we're going to do this yet. There is a couple different ways that we can do this. We just need to figure out what the best way to do this. So first things first is let's take this thing half apart, let's get all the plastics off, and let's get this engine out of the frame, and then we can come up with a game plan on how exactly we're going to do this. Wow. Yeah, it looks like this frame was patched up with a MIG flux welder. There's a weld right here, weld all along here, and on here, and on the top engine mounts. That's also re-welded. Yeah, that one's a bit rough. Man. Whoops. I forgot that there's oil in here. What am I thinking? I forgot to drain the oil. Whoops. So there's no crush washer on this. It's a plastic washer and a metal washer for the drain plug. Also, there's some yeah, that's not what you want to find in an engine. Yep, I completely forgot to drain the oil before doing this. I know, whoopsies. Yeah, everything looks pretty good. There's no rust. There is a lot of like grime or sludge buildup. I mean, look at that. That's yeah, but that's pretty typical for an old engine like this. So So, I basically spent the entire day yesterday trying to figure out the best way to do this. How do we connect this electric motor to this gearbox in the simplest, best way possible? Now, like I said before, there are two different ways we can do this. There's the easy way and then there's the hard way. And both have their advantages and disadvantages and everything. Now, before I explain the two differences, or the two different ways we can do this, let me first explain how an engine like this works. So for those who don't know how an engine like this works, they can follow along. Now, this right here, this is the crankshaft. This is the essentially flywheel of the crankshaft. This is the connecting rod. The piston mounts right here. Piston moves up and down, spinning the crankshaft. That in turn spins the clutch basket, because this sprocket right here, whoops, it's falling apart. Hang on. This gear right here spins the clutch basket, because there's a gear right on the back of the clutch basket. The clutch basket then spins the transmission. Transmission spins the output sprocket. Now, the easiest way to do this would be to simply just remove the crankshaft and machine a new one that still has this gear right here. This is the output of the crankshaft, but instead of having this giant flywheel and this connecting rod, it would have a spot to mount a sprocket, basically right around there. And then all we'd have to do is simply take this electric motor, mount it above this engine, and then put another sprocket on it, connecting both sprockets. That's the easy way of connecting the electric motor to this gearbox. Now mechanically it's more complicated, it's more moving parts, and it'll be noisier simply because of the chain and sprockets. But the harder way to do this, but mechanically simpler way to do this, would be to again remove the crankshaft and mount this electric motor further into this gearbox. We would have to cut a lot of this gearbox to make room for it, but you know, we're removing the crankshaft, so it's just empty dead space anyways. And what we would the hardest part of doing it this way would be we would have to machine custom gears. The first one would connect directly to the electric motor, but because of the size of this electric motor, I can't get it close enough to directly mesh to the clutch basket, so we would have to machine another gear that goes in between the electric motor and the clutch basket, and essentially directly connecting the electric motor to the clutch basket. That's the simplest way to do it mechanically, and the quietest way to do it. But the hardest part of doing it that way is not only mounting this engine further in the engine case, it's a lot of welding and all that kind of stuff, but the hard, challenging part would be making custom gears and hardening them. We have to make sure that we harden them properly, so therefore they last more than a couple hours. Now, I'm more leaning towards the harder way to do this because I've always wanted to learn how to machine gears and how to harden them and everything. And I think this would be the perfect project to learn how to do this kind of stuff on. I have been doing a little bit of research on how to cut gears and how to harden them and everything. So I kind of know a little bit, but I want to learn more, and I've always wanted to try it myself. So I think let's do it. I think let's do it the harder way. It is going to take a little bit longer, but I think it'll be more fun. The challenging part of this will be more fun, and we will learn a lot more and learn how to machine custom gears and harden them and everything. So yeah, I think let's do it. Let's try to do it the harder way. I think it'll be a lot more fun. Alright, so this is several pieces of large round stock that I have. I'm trying to figure out which one is the best one to use for making these gears. Now, last night I did a crash course in hardening gears, what metal you should use, higher carbon content, lower carbon content, case hardening, trying to figure out just what metal to use. Should I use lower carbon? So basically what I figured out over just a couple hours of research is you want a lower carbon content, so therefore you can case harden it. That's going to be the best thing for a gear because that'll have a hard outer shell and a soft center, which is what you apparently need. Now, how to tell the carbon content of steel is basically just spark testing. When we're looking at the sparks and seeing how much bursting or separation of the sparks, The higher carbon content will have more bursting and more separation of the sparks. A lower carbon content will have less bursting and separation. So I do believe this is the one we need. This should be lower carbon steel. Notice how you see a little bit longer sparks, a little less bursting and separation. This, I believe, is a higher carbon content. A little bit shorter of sparks, but more bursting and separation. And this is actually a good test. This is a gear. This will be either case hardened or made of a higher carbon steel. So this should be high carbon steel. This is what high carbon steel looks like. A lot shorter of sparks and a lot more bursting or separation. So I do believe this is the one we need. I think. I hope. I don't know. I need to do some further research just to verify, but I think this is the one we need. Time to bring out the big guns. Oh, man. Man, that thing was on there. say that is perfect right there. So we got the gear blank. To this point, obviously the next step is we need to start cutting the actual teeth. Now, luckily I'm a pack rat and I refuse to throw anything away. A couple days ago when I was trying to figure out like, can I do this? I was searching through all the bins of just random stuff I have, trying to see, do I have any gears that will work for what we are trying to do? Most of the gears I have are off of riding lawnmowers and they don't have the proper tooth profile, but I found this. This is the exact gear that we need. It's the exact diameter and most importantly, the exact tooth profile we need. This meshes perfectly with the gear on the clutch basket, which is perfect. I did verify that this is the proper profile, tooth profile that we need. Now, this makes it a whole lot easier making these gears because we can simply just copy the dimensions off of this and use it to machine the gears for this. Copy the diameter, the tooth pitch, and everything. And I was considering using this and just figuring out how to attach this to the electric motor, but because we need two of them, I decided just to use this as a template and just make new ones from scratch. Now, normally when you're cutting gear teeth, you use these things. These are actual gear teeth cutters, but unfortunately, these are designed to cut teeth that are a lot smaller than these teeth, but this one is so very close, so close to the actual tooth profile that we need. Yeah, when I saw that, I got really excited this morning that awesome, we don't have to make cutters from scratch. We can simply just use this one, but if you actually look at it closely and if you actually hold this up to the light, you can see daylight through it on the very bottom and a little bit on the edges. So even though this is so very close to the tooth profile that we need, this isn't the exact one. And if you actually look at this, so because how gear cutters work, you need a specific tooth profile depending on the amount of teeth for whatever size gear you're making. So this one is designed to cut a gear between 55 and 134 teeth, and this is a 34 tooth sprocket. So that tells you right there that even though this is so very close to the exact profile we need, it's not the exact one we need. So, but what I can do is I can simply take a couple of these 1/4 inch end mills that I have that I've chipped the tips off of. I can grind these down and very carefully, it's gonna be a little tricky to do this, I can very carefully get these to the exact profile that we need, and then I can sharpen them and cut a little bit of relief. But I honestly don't think that using this as basically just a single tooth cutter, I don't think one of these is gonna be able to cut all these teeth to full depth without having issues of them dulling, and then we need to remove them and resharpen them, which you can't do while cutting teeth. So what I am gonna do is I'm actually going to use this and cut to 70% the depth that we need just to be able to get rid of most of the material, and then I'll use this to cut to full depth. That way we can get the proper profile we need, but this isn't removing the whole bulk of the material. So we can simply just use this for the finishing pass. So now let me spend some time grinding these down. It's probably gonna take a little while to get these to the exact profile that we need, but I think if I'm really careful, I think I can do it. And then I can start setting up the vertical mill to actually start cutting the actual teeth. That is perfect. Alright, so all I gotta do is line this up perfectly with the last cut that I did, and then do all that again at full depth of cuts, and then we should have this thing finished. Okay, it is set up, it is at full depth, it is in the right height and everything. I'm gonna take really, really light cuts just because I want to be double sure that this will last for the full, depth of every single tooth. I do not want to have to resharpen this. Here we go. It's gonna clear, right? We're not gonna chip it as soon as we turn this on, right? Okay, here we go. I'm a little nervous. Holy crap, I had to go so slow with that. This is going to take absolutely forever if I have to go that slow with each one. Good news is the cutter looks fine. It's making some not pleasant noises, but it's working, I guess. How does the tooth look? Ooh, it looks good. It looks good. As long as it stays that sharp for this whole thing, we're looking good. Okay, let's move on to the next one. Holy crap, is this slow? But I'm really, really taking my time. I do not want to snap the cutter, so I'm going extra slow. Right now, I am almost halfway, or actually a little bit more than halfway, so thankfully. I think that is the last cut. Nice. Somehow the carbide cutter survived. I am really glad this thing did not snap in half halfway through. So one thing I really need to check is, let me go to the next tooth, which we've already cut, and then I'll check the clearance between the cutter and the tooth just to verify that the cutter didn't move around halfway through. Yeah, the surface finish is almost perfect. Look at that. It's amazing. Now, how does it mesh with the gear that we're trying to copy? So, nice. Look at that.
Alright, that actually wasn't too bad. Now, I'm really glad I decided to do the actual gear cutter first to take off most of the material and then do the finishing pass with that thing, because that cutter took 3 times longer just because I had to go so slow. I was afraid of breaking it or chipping it off or something. I had to go so slow with that thing, but we eventually got it. I did double check to make sure that I got every single tooth, and I also double checked that the cutter didn't move or anything halfway through. I did double check to make sure that each one of these teeth is at full depth. So now that that's done, we can put this thing back in the lathe and finish it up. I have all this material that I need to remove, and then this thing's pretty much finished.
So, I do not want to say how many days it took me to machine this thing. That was definitely the longest time I spent machining just a single piece of steel, and I still need to make another one. This is only the first one we need out of 2, and we also need to harden these things and not mess it up, because I do not want to have to remake this thing. Now, what I did is, because we need to harden these things, because I've never kind of done that before, I bought a kiln on Amazon that was like $650, which that's going to be nice to have, so I don't have to rely on propane burners to try and, you know, heat these parts up. Also, I cut 2 discs out of the material that I used for machining this thing. I cut one that's 1/2 inch and one that's 3/8 of an inch, and I'll cut those into strips, and I'll use those strips to do test pieces on case hardening them. I'll do 3 different ones. I'll case harden one for an hour, one for 2 hours, one for 3 hours, just to figure out which is best for this kind of material. And then I'll harden all of them differently to kind of just figure out what is the best way to harden them before actually trying to harden this piece, because I do not want to mess up this piece by hardening it wrong or not knowing what I'm doing. So, now, we're probably going to make the second one in the next video of this project, but for now, just so we can see a bit of progress getting done in this video, I want to start figuring out how to get this electric motor into this engine. So, let me take this whole thing apart. I'll clean it heavily. I'll remove all the bearings carefully because I need to put them back. And then let's start cutting into this engine case and figuring out how to mount this electric motor into this engine. So I've been trying to figure out a good spot for this electric motor. I think right there is going to be good because we don't want it to be too close, and then the spacing for the gear that's going to be going in between the electric motor and the clutch basket doesn't have enough spacing. But I think this height is pretty good. So the gear on the motor is going to go there, and then the gear for going in between the electric motor and the clutch basket is going to go right there. So I think that's perfect. There's also enough material to leave this engine mount. It's clear enough from the transmission side of this engine case. I can mostly leave this breather part of the engine right here. Yeah, I'm not really sure yet on how exactly I'm going to cut this engine case. It's probably going to be a combination of my bandsaw and the vertical mill. If I am using the vertical mill, I need to figure out exactly where this engine's going to go, or the motor's going to go, and then probably use reference points of bolt holes to be like, it's 7 inches from this one, so I can get it lined up perfectly in the vertical mill, and then just use probably my adjustable boring head to just keep taking material off until there's enough room for the engine. And then I have this 3/8 plate. I'm going to cut big chunk out of this. I'll cut a giant circle, so therefore the motor can bolt onto this, and then figure out the exact position of this and then weld it in place. And that's pretty much how we're mounting this electric motor in here. We have, the most important thing is getting the spacing this way, because we need these gears to line up. Specifically, we need to get these gears to line up with the clutch basket. So we just need to figure out the exact distance where it's going to be on the motor and all that. So yeah, slowly figuring this out. Tomorrow we'll start cutting the engine case, and then once we do that, there's no going back. It's the point of no return tomorrow. Yep, there's no going back now. We're definitely committed into doing this.
Alright, I just gotta trim off just a little bit more, and then it's time to put this in the vertical mill and machine it perfectly round.
So this is the general idea on how this setup is going to work. We're just trying to get the electric motor mounted as far down into the engine as possible without interfering with the part of the engine that's the gearbox or anything. Also, we are going to have to heavily modify the dirt bike frame to get the battery to fit. So that's why I'm also trying to get this electric motor as far, because the lower we get the motor, the more space we have for the battery and all that kind of stuff. But now, next video, we get to mount the electric motor in this engine, as well as start machining the other gear that we need. I've also been watching a ton of videos on how to heat treat these things properly. I know it's a little risky, not using a known steel, but I do believe that this is either low carbon steel or medium carbon steel. Even if it is medium carbon steel, we can still case harden it, we can still heat treat it. It's going to be a little bit harder in the center than if it was low carbon steel. But I think it's still going to be heat treatable and case hardenable and all that kind of stuff. So I want to make sure I do it right, because I want to make sure that these parts last a good long while and not just for a couple hours and then they start just self-destructing into nothing. So also, I do know this isn't really a new concept of an electric dirt bike that still has gears and clutch and everything. There are actually a couple companies out there. I can't remember the names, but there are a couple companies out there that do make electric dirt bikes with gears and a clutch and everything, as well as I do know that there is a motorcycle out there that still has an electric motorcycle that still has gears and a clutch. So this isn't really a new concept, but I still think it's a lot of fun building it ourselves, and basically just the challenge of trying to take a normal dirt bike and install the electric motor in the engine and all that kind of stuff. It's the challenge of, can I do this and how well will it work? That's the part about this stuff that I enjoy. But anyway, guys, that's it for this video. Thank y'all for watching. I'll see ya in the next video.
Okay, I just heard a noise that you do not want to hear after spending how long I spent on that. I hope that didn't happen what I think just happened. Ah! Really? I just snapped my cutter. I spent so long on this. Yeah, I was tightening this, trying to get it really nice and tight, and then I heard a snap, and I'm like, that better not be what I think it is. And sure enough, yep, I broke it. So either I can push this in a little bit further and hope that that's enough to hold it in place, and then just don't tighten it as much this time. I mean, we probably don't want too much stick out. So I'm trying to tighten it again, and I'll be honest, I'm not liking the sounds I'm hearing. So because when you crack or split in half something as brittle as this, it could also create other cracks, and trying to tighten this is just making those other cracks bigger, because this feels really crunchy every time I try to tighten it. Oof. Okay, it's starting to tighten. Now it's just a thing of how much do I tighten it? Do I risk it? I don't want this to move. I don't. Come on, just cooperate for me. Okay, that is tight enough. I'm just gonna take really, really light cuts and take my time. I was trying to check the depth, and I chipped the very tip of it, so I had to take it off, regrind it, resharpen it, put it back, and cracked it in half. So yeah, this has been an ordeal, but we're halfway through. The first one, at least. Oh, wow. Thankfully, it was just this cheap tool that broke and not anything in the engine. Wow, that's kind of surprising. You'd think a tool that's designed to hammer on would survive being hammered on. That's kind of surprising. Look at this. Yeah, this broke in 3 separate pieces. Look at that. That's nice. Nice quality tools. What brand is this? Oh, Pittsburgh. Surprise, surprise. Harbor Freight. Yeah, that's what I get for buying cheap tools.